All right, hello everyone. Today I'm going to talk about Web Components and StencilJS. It's a new tool from the team that made Ionic Framework, and it's pretty neat. We're really excited to tell you all about it. So before we dive into that, let me just tell you a little bit about myself. Once again, my name is Dan. I'm on social at Dan Buchholz. I'm always trying to add followers and all that stuff. So if y'all want to follow me, it'd be much appreciated and very awesome. My role for Ionic is I'm a senior developer. I work primarily on the Ionic Framework, the open source project. If you're not familiar with Ionic Framework, it's basically a way to build mobile apps using web technologies. So you'll get like the UI controls that look just like an iPhone app or an Android app, but it's all done with web technologies instead of Apple's tools. So right now I'm the #2 contributor on that project, which is really cool. It's really neat to work on such a huge project. I am not very good at CSS. I'm definitely more of a JavaScript guy, so if you have any CSS questions or anything, I'm probably gonna punt on that one, because it'll be a disaster. Personally, I'm really into like hanging out with my family. I love the Wisconsin Badgers, like borderline obsession, and also tacos, all kinds. As far as dislike goes, I really hate JavaScript framework wars. Like this is the latest thing all over my Twitter feed, and it is just the frickin' worst. I cannot stand it. They're all the same, as we'll dive into later here. I also really dislike CSS. I think it's kind of hard to use, which is why I like Ionic, because we make it so easy and you don't need to know CSS to get these really cool, beautiful components, and even to like skin them or theme them to match your brand, you don't really need to know very much CSS at all. I also really dislike the Windows command prompt, just awful. Okay, so modern web development sucks. Like the tools itself are really great when they're working. That's probably the best way I can describe it. It's super easy to write code these days. Like if you use like Angular or Vue or React, it's really, really easy to crank stuff out really fast. It's very, very easy in the browser. But the tooling behind the scenes is absurd. Like, I bet there are tons and tons of 1,000-line Webpack configs. And for what? Like, it's just a build tool. And then there's also not really one true way or defined path to build an app. Right? Like if you look at any Google Docs around doing web development, never do they mention the word testing, because there's no one true way to write automated tests for your web app. Instead, you've got like 50 million different tools out there that all work slightly differently. Half of them don't work. It's just a disaster. Another thing that we have going on right now is that all of these modern tools are really, really slow on mobile. That's what we're seeing at Ionic. So we bet on Angular 2, which is the successor to the wildly popular Angular 1. And we're seeing it not really catch on as much as we would expect. It has like 1 million downloads a month, which seems like a lot, but when you think about all of the developers in the world, and you know how many times we all npm install every day, I mean, I do it like 50 times a day, and I can assume most of you guys do the same, it's really not that much. It adds up quick. So basically, these tools are really, really slow, and I would say they're not catching on as much as we would like. The other thing that we have going on with these modern tools is they're very segregated, right? So we have Angular 2, React, Vue, Ember, all of these great tools to build apps, but they can't talk to each other at all. If you want to have one widget on your website built with Angular 2 and you want to have another one built with React, well, you're pulling down like 10 megabytes of JavaScript and your app's going to load in 35 seconds on your cell phone. So that's kind of a non-starter right there. The third and final thing is it's not standard based, right? These component models, or like how Angular 2 works or React, these things are just made up fairy tale things that some engineer came up with. They're like basically JavaScript constructs that the browser doesn't know anything about. Just somebody hacking code together until it works. So that kind of brings us to where we are now and what this talk is about. So I wanted to talk to you guys today about web components, which historically has kind of been a dirty word. We'll get into that a little bit later. But what web components are, they're basically a standard JavaScript module. So if you look at Angular or React or Vue, again, I'm going to say those terms a lot. I'm assuming most of you know what those are. They're ways of building apps, essentially. All of those tools provide a component model. Well, with web components, the browser actually has a standard built-in component model. The thing is, nobody uses it. It's not like a well-known thing until very, very recently, and we're trying to change that. So how a web component works is it's basically a div that magically comes to life. So if I just throw a div, a div doesn't need to have the div tag. It can have any tag name that you want. With a web component, this thing's going to come to life and actually become interactive, run some JavaScript once it gets attached to the DOM. So web components are very loosely inspired by these JavaScript frameworks, as in they have a way to take attributes or props, if you will, in a sense, from the user, and basically as parameters you can pass stuff to them, and you can create a class or an instance, excuse me, for these components behind the scenes. It's a little bit inspired by React, I would say. Web components will ultimately be, in our opinion, the solution to this shared component problem. If you look at every WordPress website out there, there's a million widgets that you can just install by installing a plugin, right? But all of these are built with like React or Angular, like I said. These things are not built into the browser itself, so when you install these widgets, they pull in their huge framework with them. Next thing you know, your page is really, really slow. So we think web components are going to be the answer to the shared component thing. The most important part of web components, in our opinion, it's called the custom element spec. The web component spec itself is really a set of specifications. There's like 4 of them. The one we're going to focus on today is called custom elements, and that's what makes that plain old boring div come to life. The other thing I should mention is that the browser support for these web components is actually really good. If you look at what browsers people actually use, the vast majority of people are using Chrome. Then you've got Safari kind of dragging the heels down there, but some people use Firefox, and then some people use Edge. But by far, the most people are using Chrome, and Chrome has first-class support for all of this. Safari does as well. So let's just take a quick look at what a custom element actually looks like. So if you're writing HTML, right, like I was talking about before, you can pass in, or basically you're making a div, but you can name it whatever you want. This could be Dan's Tacos, or Dan is a bad speaker, whatever you want to call it. And then you can pass in arguments to it. So just like any other old school tag on here, if you're going to go really old school and use like height rather than style, it's the same concept, right? You're passing data to this, it's parameters. So when you're actually, hey, can you guys all see this? It's even hard for me to see. In any event, so let's talk about how this actually works. If you were to create a web component and you wanted to get started today, what you do is you create an ES 2015 class and have it extend HTML element class. Then below that class, or really anywhere after you define this, you just call document register element, and you say, hey, this class, or constructor if you will, is associated with this tag name. That's really the meat and potatoes of these custom elements. The killer app of a custom element, though, are these callbacks. The interesting ones being the attached callback, which fires when your element gets attached to the DOM, and then your detached callback, which fires when the thing leaves the DOM. Likewise, you have an attribute changed callback. I would say that it's useful in some cases, but for us, we found it wasn't overly useful. It really depends on what your use case is, I would say. So that's kind of the meat and potatoes of custom elements. So we were pretty stoked about the idea of using web components at Ionic because we could decouple ourselves with web components from Angular. So Ionic Framework itself is built on top of Angular right now. And all of the internals have all kinds of Angular code in there. What that ultimately means is if you're some shop in Milwaukee using React, which is a far more popular tool, you can't use Ionic. So that was obviously a bummer. So one of our big goals here with pursuing this is that we wanted to be able to attract developers that are using a different toolkit. What we found when going down the road with web components is that they work awesomely when you're up and running with them, but it's kind of hard to build these and make them real components. If you look at the browser primitives, we've kind of found them insufficient for building web components. What we wanted were things that we were used to in frameworks like React or Angular, such as data binding, virtual DOM, or efficient repaints, if you will. templating, TypeScript support. So we use TypeScript for everything at Ionic, and you could, in theory, use it with web components, I suppose, but it's not necessarily a natural fit unless your framework is kind of built on TypeScript because you don't have all the typing information and all that stuff. The other thing that we really wanted was opinionated testing, right? As I mentioned earlier, there's like 7 million testing utilities. None of them really are anything to write home about, I would say. So that kind of brings us to where we are now on the topic of today, which is Stencil. Stencil is a compiler for web components. It's not really a framework, it's more of a compiler. When you write code for Stencil, it's all of a build time construct. All of the fancy Stencil code is gone when the thing actually gets deployed, and you end up just deploying a vanilla web component. So the big killer app for us was that this Stencil compiler adds framework-like features to your web components, for the main one being data binding and efficient refreshes. So we created this tool specifically for us, and we found it to be so awesome that we wanted to open source it so other people can use it and take advantage of it. Ionic 4, which is our next version of Ionic, due probably in a month or two, is built entirely on Stencil. And what that means is we got rid of all of the Angular code from our code base and rewrote it all with Stencil. So let's before we dive into essentially how Stencil works, let's just talk about why you would want to use something like that. So if you look at these frameworks that I was talking about, Angular, Vue, React, they're all really nice from a developer experience perspective, but when you're actually deploying your app, what we found is that they're just too slow on mobile. Like if you look at Angular 2, when you compile a Hello World app, it's like 200 kilobytes minified just to say hello world. Like that's kind of absurd. If you fire that up on an old phone with a 3G connection, as is prevalent in much of the world, it takes like 10 seconds to load. And just to say hello world, like if you were to just put that in a web page, it would take, I don't know, 1/10 of a second, 1/20th, just ridiculously fast. The other thing is stability. If you look at web standards, basically the web has always been backwards compatible, and they ensure backwards compatibility. What that means is a component that you write today with Stencil will always run for the next, well, for the foreseeable future certainly, but the marketing phrase we like to use is for the next 20 years. I mean, it's obviously impossible to predict the future, but if you made a website 20 years ago following web standards, there's a very, very good chance that it will still run today. I mean, if you just throw a div on a page, right, and throw some JavaScript around it using query selector, all that stuff, that's going to run forever because that stuff is like the foundational building blocks of a browser. Well, that's what web components are. The other big thing, interoperability, we talked about that already. These components run anywhere. So let's dive into the developer experience of Stencil. So here we have like your hello world Stencil component, if you will. So the first thing you'll see at the top is you have an import statement. This is a standard ES 2015 import statement. And you're just going to import a couple things, we'll call them for now, named imports, from Stencil Core. Stencil Core is the package that we deliver on NPM with all of this, with the Stencil compiler. So we import the component, which as we see in usage is a decorator. Now the component decorator is just it's a build time construct to associate a class, in this case my name, with a tag name. So we have my hyphen tag. With web components, according to the standard, every web component must have the hyphen in the name. So it can be Dan's hyphen tacos, Matt, whatever, it doesn't matter. But you can specify a tag name. It's not auto-generated. Perhaps we'll add that in the future, but for now you must specify a tag name. Likewise, you can also specify the location of a Sass file. So we made Sass a first-class citizen in Stencil because, again, we built Stencil for ourselves, and we use Sass for everything. If you want to just write vanilla CSS, by all means, do it. That's what I do because I'm a CSS noob. But Sass is built in, so you can do some really cool things with mixins and functions and all that jazz. So if we look at the next thing that's actually imported, this is called a prop. And again, if you drill through the source code, we see that prop is a decorator here. And prop is a term made popular by React, and it was also adopted by Vue.js. Basically, a prop is something that you pass into the component. As I was talking about earlier, we had web components are primarily based on like attributes, which are always strings. Well, that's kind of a bummer if you're building like a serious app. Oftentimes, you'll want to pass parameters that are not strings. You'll want to pass properties. Properties can be really any type, right? They can be the primitive types, they can be objects, they can be arrays, whatever you want. So by using this prop decorator, it basically says, hey, don't use the attribute, use the property instead. So that basically is the way that you pass data around. It's just like React, it's props. For those with a sharp eye here, you'll notice a type definition here. So we have colon string. That means, or that's essentially a type declaration in TypeScript. So Stencil only uses TypeScript right now. So if you're using Stencil, you will be writing TypeScript code, and the world will be better for it. So down here, we just have this render function. And this is where we think Stencil gets really, really interesting. Who here has used React? Can I just see a set of hands? OK, so just about everybody. Well, JSX is this concept that React has. And most of you know about it, but in any event, JSX is a way to basically make a declarative template in your JavaScript class. Well, Stencil uses JSX for all of its templating as well. So once you compile this actual component, it strips out all of that Stencil stuff, like that prop, that component decorator. None of that stuff exists in the code that you deploy because that's just frivolous extra stuff. It's really a compile time construct. In addition to that, we have a small runtime on top of this raw component that basically adds a virtual DOM layer so that your updates are super efficient. If you look at like React, they kind of created or pioneered the virtual DOM concept. And over time, this has really evolved, and people have like taken this thing to the max and made these super tiny implementations of it. So we found one called SnapDOM, and we've basically shoehorned it into Stencil, and it's working amazingly well, and it's tiny. It's really fast, and the file size is minimal. In addition to that, and this is, in my opinion, the killer app of Stencil, is that every component itself lazy loads its own implementation. So while it looks like you're writing your web component with your template and then your ES 2015 class, really in the build process, we separate those a little bit and we lazy load that class on demand, and then it'll fire up and it'll receive a set of callbacks when it's ready to go and initialized. What this means is that no matter how big your app gets, let's say you're building Gmail or something with like millions of components, it's always going to have a lightning fast startup because the file or the initial download will never exceed like 7 kilobytes. It's just crazy how small this thing is. And then, like I said, it lazy loads everything on demand. The other thing is reactivity. I don't really like that term, but basically, your Stencil apps or components are reactive. Whenever a prop or something called a state variable changes, the thing will efficiently re-render. Okay, and this is really cool. So how many of you guys have heard of React Fiber? Okay, I got a few hands in the back. I like that. So this is like, you've got to be a super nerd to know about that. But React Fiber is the new version of React that just came out today, actually. And what's new and interesting about it is React, or the React team, found that when you're building these apps, where the web is slow is that, or where they're seeing like performance issues or slowdown in React apps, is in user code, basically, where they're just doing too much stuff in one frame. So what React did was they came up with this concept of like a worker queue, where every time you need to do like a DOM update or something, it adds an entry to this queue. And then there's this new functionality built into the browser called request idle callback. And basically that says, hey, I'm cool, I'm not doing anything right now. Let me call you back, see if you've got anything you want me to do. So this request idle callback fires whenever the browser's just chilling, and it pops items off this queue and starts like doing the work, which makes the rendering asynchronous. And React Fiber is smart enough to say, hey, I can only do this amount of work within a frame. and then it just chills out and waits until that request idle callback comes again. What that means is that your apps are like stupid smooth. Basically, it kills jank, right? Because you're not trying to do too much, you're not animating too much or anything like that. The browser's optimizing the amount of work that it can do in a frame. So we borrowed that concept from them. Since Stencil, everything is lazy loaded, like I mentioned, everything is already asynchronous by nature. Pretty much any API that you would write with Stencil would have to be asynchronous, which as people working on the web a lot are finding, that's a lot better for performance. We already have this async nature built in. It was super trivial to move over to like this queue-based rendering, and it works awesomely. What we are seeing is we are right there with React Fiber in terms of performance, which is pretty incredible. I do have a demo that I can pull up and show you guys that. The other thing is web components historically, if you look at like Polymer, that's the other big web component project. Nobody really uses it or knows about it, so I don't even really mention it, but they were like the guys that came up with web components. They're a team at Google. They cannot do any sort of server-side rendering. Well, with Stencil and the Stencil approach that we took, everything is designed to be rendered on the server, so you can basically server-side render your page, serve that up really fast, then hydrate your JavaScript using the lazy loading mechanism, and it'll all just magically come together and be super fast. Okay, so the Stencil itself, as I mentioned, is a compiler, and it just has a super minimal API. Like there's really nothing to it. Like I mentioned before, we have that component decorator, which is where you define the metadata around the tag and potentially any SAS files you want to compile. The prop decorator, which says, hey, this is a property where you're going to pass in dynamic data. There's also this notion of a state, where basically, let's say that you wanted to compute some value within your component, and when that value changed, you wanted to efficiently re-render. You would use state in that case, because prop is for things that are passed into the components. State is just a local variable to the component itself or to the instance of the class that you want to make active or involved with change detection. Likewise, we have this notion of an event emitter, very similar to how Angular 2 works. And we also have the ability to declaratively listen for events from different components. And we also have an element decorator to grab the host element. Super simple API. So let's just do let's just do a quick demo. Let me just show you guys how this thing works. Okay, so first things first.
You want to crank that size?
Yeah, definitely. Okay, I'm sorry. I'm jumping around too much here. Let me do this. This will work. So this is a sample stencil project, and we have this on GitHub. You can just clone it if you want to play around with it. Let's just dive into, first of all, what does the HTML file look like here? So I'm going to make this guy a little bit bigger. But the first thing that you'll see is you just include this build app.js. So basically this is some file that you build. Then down here, you don't have any like Angular, Vue, React code. You just have your custom element right here. You just throw it right in there in your code and it's going to magically work. So let's fire that up and see what it actually looks like. So I ran from our starter, I just ran npm run dev, which fires up a development server, enables live reload. And sure enough, right off the bat, I've got, hello, my name is Stencil. So now let me show you guys something pretty slick. Whoops. So if I look at my inspector here, the first thing that jumps out to me, and I'm sorry, it's kind of small here. There we go, I can make it a little bit bigger, is we have this kind of, it's kind of funny to me actually. We have a little diamond that we just assign as a class, which says, hey, I'm a hydrated element. So we really have two states of these components. We have the non-hydrated state where it's just a custom element. And then like I said, we lazy load your implementation. So once that implementation is lazy loaded, we then consider the element hydrated. So this guy right here is hydrated right away, and that means once it's hydrated, it populates its own children. Let me show you how that actually works quick. So in the component itself, and again, we have a .tsx file extension because this is JSX, just like React. So you have .tsx, which is TypeScript's version of JSX. Inside this component, in my template, I just have some div and a hello, my name is, binding to the first prop, and then binding to the last prop. Again, those are just arguments that you could pass in. In this case, they happen to be strings, but they could be really anything. They could be objects, arrays, whatever you need. So now let me show you the interesting thing. Since this is just a web component, I'm gonna get a little wild here in my console. So I'm going to create a new element on demand. So what I did here is I just called document.createElement and passed it my name. I'm going to append this to the body right now, and we're just going to see that thing come to life right away. Because again, it's just like a div to a web developer. There's no difference. So this is a standard DOM API that, like, this is web development 101. So just append an element to the body. So right off the bat, it creates a new element in here. And since I didn't set the props, it's obviously not rendering that. But it created the element, added it to the DOM. And while this example itself is trivial, imagine if you were doing something complicated, right? Like, you could abstract all of this crazy logic into this simple component that your web developers that use WordPress, or, you know, let's say you have 50 web properties and you want to make a shared login page or a shared header or something like that. You could easily do something like that with a web component, spread that throughout your organization. I mean, the challenges there are not obviously the code. It would be like communication based. But you can make this reusable component and you can use it across like any of your web properties, and it's just amazing. The cost savings could be huge. Okay, so that's kind of what it looks like when you use Stencil. That's just the basic like hello world demo. Obviously we could go more in depth, but for the sake of time, we're not going to go too far here. So how is Stencil different from all of these other tools that everybody's talking about these days? Well, the big one is that it's a native element, right? It's built into the browser. It just works. You don't need to have gobs and gobs of JavaScript in this huge heavy-handed framework. You know, you don't need a 500 kilobyte hello world just to run this app. This is something that's built in natively so you can save on your whole component model from your code and just focus on what actually matters, which is delivering your app. Another question people have been asking us is how is this different from Polymer? Well, I would say nobody even uses Polymer anyway, so I kind of consider it irrelevant. But basically, it's just our interpretation of how it should work. We really like React at Ionic, huge React house, even though Ionic itself is built on Angular. But we think React is a really pleasant developer experience. So we modeled much of Stencil after React. So if you're doing a lot of React, this is something that you could pretty easily get up and running. And then how's it different than vanilla web components? Well, it's just a developer experience thing. We put a bunch of niceties in there to make it easy. Other than that, it is a vanilla web component at the end of the day. So getting started, if you guys wanted to try this out, and I highly encourage you to do it because I think you'll love it. So far, everyone that runs this has given like insanely positive feedback. And they're like, wow, this feels like the future. Just go on GitHub and just clone our starter. That'll just get you up and running with a basic web project, and it has everything you need in there to run. Just run npm start. So where to go next? We have a ton of documentation online. Obviously, we're not going to click through all of these. Oh, so we announced this guy like 3 weeks ago, I think, at the Polymer Summit, which was a big web component conference in Copenhagen. I would encourage you guys to check out this video. It dives more in depth into web components and what role Stencil will play. Here's some resources. We have StencilJS.com, which is our documentation site. We have a new Twitter handle for Stencil, StencilJS. And then, of course, our GitHub page. So that's really all I've got as far as like the official legit presentation, but I'll just go off the handle here and just kind of talk. In my opinion, when I look at Stencil, and just from having used it, like this feels like the future. I'm so sick of using React and Angular and all that stuff. It's just slow and clunky. And honestly, it works well, but the tooling is just crazy to get it up and running. Whereas Stencil, it's like an integrated experience. We have our own test suite and all this stuff for it, so it just works, and it's all owned by one entity, or it's all housed under the Stencil entity, so everything just works, right? Like your test suite is designed to work with the framework, and the framework itself, well, we build both the tooling and the framework. It's one team, so everything like is super cohesive and just works. You guys should check it out. If you're building stuff and using React or using Angular, try it. The thing that we're seeing is just Stencil components are so much faster than Angular, React, all those frameworks. The performance boost is just insane. And since all of these components are lazy loaded, it's really, really fast, like the time to load. So there's two kinds of fast, right? So you have how long does it take to actually load this website, which is pretty long for certainly Angular apps and kind of even React apps. But then you have like your runtime speed, which is how fast can you render and paint and how efficiently does your JavaScript run. Well, what we're finding is like Stencil just dominates the competition in both cases. So there's like this new benchmark out there called Hacker News PWA. Have you guys heard of that at all? So like it's basically everybody implements the same app using these different toolkits, and then you like do some benchmarks on them and metrics about how fast it is. And Stencil just mops the floor with it. It's like the fastest one by far. The rendering is unbelievable. Let me show you guys the Stencil site, which is itself built with Stencil. And you can just see how absurdly fast this is. Like this site loads in like under a second on a 3G connection. And it also, so once it loads, then it like switches to PWA mode. So it's kind of like a weird hybrid model with Stencil, because we have this server-side rendering, but we also, it'll just do the server-side rendering and like start out as just your fixed page that you load, but the second that it actually loads and like the browser fires the onload event, we go and load the rest of the JavaScript, and then we don't like blow away your content and initialize your PWA. We just jump on and attach to the existing elements, so you'll never get like flashes or anything. So overall, I think it's really cool personally, outside of like the sales pitch stuff. I would encourage you guys to try it. It's gonna be the backbone of the next gen of Ionic. So it's pretty legit. There'll be several 100,000 people using this tool in like a matter of months. So it's gonna be a big thing. We're really excited about it. I hope I didn't bore you guys or overwhelm you. But yeah, check it out. It's pretty cool. Thanks, that's all I've got. Does anyone have any questions? Matt.
Can you humor me? If we go back to the one you were running off your laptop.
Sure.
Does it watch, like if you set attribute, will that populate? Like if you set attribute on your LED?
I could do that, but I'm gonna do you one better. So the set attribute, that would be the attribute itself, whereas we're watching the prop. I don't remember what it's actually called, so give me 2 seconds to figure that out. Okay, so first and last are the props, so let's set one and see if it actually works. I think it will. Boom. Yeah, it's just an element, so I could do the same thing with last. I think this is how you spell it.
Good job.
Boom. Yeah, it's pretty neat. Like I said, it's all reactive. We're just watching the stuff in the background. And like I said, the actual payload for Stencil is like stupid small. It's like 6 kilobytes or something like that. And the nice thing is, since we own all the tooling, like if you look at Angular, like their tooling is kind of a nightmare of like all these different tools, and they're built on top of Webpack, which they don't own. So they're like beholden to Webpack and what their priorities are, and all of these, basically it's all these unrelated tools like put together to form this one thing. To some extent, we have that a teeny bit with Stencil, but for the most part, we own the tooling. And the approach that we're taking with this is we want to use web standards as much as possible. So right now, this is not using like ES module import directly in the browser, but we intend to add that in the coming weeks. So like you'll be using the super legit dynamic import and like, or your static imports at the top if you want. But the goal is when you write Stencil app, it's all standard compliant, and you're going to use actual ES 2015 imports and exports and pull in code, which we think is really cool because bundling sucks. Like if you try and use Rollup, which is a really good bundler, it's just really hard to work with third-party libraries. Like the code that it outputs is awesome, but it's hard to use. Whereas Webpack, it's really easy to use, but the code that it outputs is shit. We think this is a much better approach to like download the smallest amount of code possible. Yes?
So one of the frameworks you didn't mention was Ember, which is kind of known for its opinionated kind of, and brings everything there and included.
Yeah.
Similar. How do you think those kind of compare, Stencil and Ember?
We really like Ember. I'm good buddies with Chris from the Ember team actually, so I have nothing but good things to say about them. As far as like how the tooling works, we offer a lot smaller surface area. Like Ember's kind of all-encompassing, and they provide everything, and they do a great job of it. But what we found is that Ember, if you like follow them very closely, they have a ton of performance issues. So where we were focused with this is like, how can we make the smallest possible slice to create awesome apps so that they're fast? Because our whole thing is, so Ionic, as I told you guys earlier, is a company that makes basically mobile apps using web technologies. So we are compared constantly to native apps. Like if you fire up Twitter on your iPhone, it's super fast. Everything's silky smooth and really nice. It looks like, you know, $10 million app, like 20 of the best developers in the world probably built it. Well, that's constantly like the standard that we're compared to, so we really focus on speed above everything else. But in the case of Stencil, you know, it's not only fast, but the developer's experience is actually really awesome too, so. Yes?
Can you explain the process of how I take this super great component you just made and how do I put it in a different website that doesn't have all your tooling and all that?
Yeah, absolutely. Let me show you. So actually, I will show you a great example, and this is like the roughest. It's a good example and that's cool and that it works, but it's actually super rough in that we are not doing it in a legit way at all. So this is a React app using Create React app, and I wanted to include Ionic components into it just to test. And rather than like distributing it over NPM or doing it, you know, legit at all, I just kind of copied and pasted in our Ionic repo of Stencil components right now. So what it looks like is you have like a main file that gets output, and of course this one's super Ionic specific. You can like specify the things that you want to put in there, but you have like this tiny file, and I guess it doesn't look too tiny because this is all of Ionic in it, but your main.js file ultimately says, hey, these are the elements that Stencil knows about, and you just put that guy in there, and then this guy has some paths in it that are associated with basically where you deploy it. And again, this is all configurable in your build process essentially for it. But so you, all right, long story short, it's going to get too complicated to dive into the nitty gritty. You copy and paste your dist folder and it'll work wherever. But since everything's lazy loaded, there's like a ton of JS files in here that all basically at a very specific location, and the file loader knows where that location is. And this main file is really just the file loader. It says, oh, I'm looking for a toggle component. Okay, let me go load it. That's really what this main file is here.
Dan, can you back up a level? So like this is the output that the compiler is going to give you, right? But like, okay, so you copy over the output, that's fine. But like in your index.html for like this React app, like what did I have to do to actually use the component? You know what I mean?
Absolutely, yeah. Let me show you that. You know what? I don't even know where that is in here, but let me show you just in our starter. So you just specify a file, and it's literally, you say, hey, well, in this case, we have build. It could either be dist or whatever you want to call it, but some outputted directory, and then just your app.js or main.js. In the case of Ionic, we call it ionic.js. It can be named whatever. This is all configurable. So
and that just loads that tiny file on the fly and then the element back to get the sub file that the tiny
exactly. Right. So like the core parts of Stencil, you have basically a registry of every component that could be in there, and then it knows where to find those files to lazy load them as needed.
So
but
something in the Stencil line that I say build?
Absolutely. So I didn't want to dive into that because there's some options in there, but we have like a stencil config file.
Is there like a simple page on your new site to
Absolutely.
show it?
Yes. So let me show you. If you look at that, so there's like, we have a whole section on distribution actually. So it's all just configuring basically your stencil config. But like I said, we're going to output to a dist, copy and paste that dist wherever you want to deploy it, and it'll just work. So we assume you'll be in the web root by default, but again, you can specify whatever path you'll be. Due to using web standards, this has to be trivially harder than we'd like it to be right now. And again, it's not hard, it's just trivially harder. Because if you want to do like HTML5 URLs, like client-side URLs, it's kind of funky and you need, basically your entire app needs to have full absolute URLs instead of using like relative path because you can load the thing from anywhere. So that's why all of our stuff, when I show you like the distributed files, it always is an absolute path. But again, that's all configurable and it's easy to use. Yes?
Does Stencil do anything with routing and HTTP and
Stencil itself is just the view layer for web components. If you look on our website, we have a community section here and actually it's in the add-ons, but we have a Stencil Router and it basically just makes it really, really easy to load different Stencil components. Like I said, this site itself is built on Stencil and it uses the router. This is like our dog food thing. So whenever I click a link, this uses the router to load the different page. And as you can see, it's stupid fast. Any other questions? Yes?
when you do the server-side rendering, do you, like, when you hydrate it on the server, do you, and it, like, it hits an API call or something, does it have to re-hit the API call once it renders on the website? You know what I'm saying? Like, there's usually...
Yeah, so that is configurable. So in your Stencil code, there is like an is server thing that you can check.
Okay,
So if you're on, like, let's say you want to append something to the DOM, we'll say right on startup or something like that. You want to dynamically load a different script. So you want to load like jQuery, which who would do that now? But you want to, let's say you want to load jQuery, right? And you don't want to do it right away. You only want to do it once some widget is loaded, so that your first pane is still really fast, right? So you want to append this thing to the DOM as soon as that component hits the DOM, or append that script tag to the DOM once that component hits the DOM. You would check if is server, don't do anything, but if you're on the client, go ahead and append it to the DOM. So it's all built in and factored in. All right, cool. Well, I hope you guys enjoyed it and I didn't bore you to death and it was somewhat coherent. Check it out, it's really cool.